So welcome to the Swedish NLP webinar. This is a hybrid seminar that we run every other week. So we have participants joining us online. We have the people here at the Stockholm office for AI Sweden, and we also have people at the Gothenburg office for AI Sweden. And today we actually have presenters both in Gothenburg and here in Stockholm. And today we're going to talk about SuperLim, which is a project that we have been running for a couple of years now. And this is the final presentation of the project. We will present the end results and thereby conclude the project. So SuperLim actually started 3 years ago in 2020. And the reason why we started this project is because we were working then in the language models for Swedish authorities project, developing and applying Swedish language models particularly in the public sector, but we realized that we had really no idea on how to benchmark Swedish language models. So we couldn't really tell if one language model was better than another one. And that's sort of the reason why we started the SuperLim project. And this has been running now in 2 iterations. So the first iteration was 2020 to 2021, and that was basically only Språkbanken Text, who developed a set of test suites for Swedish language models. But of course, we realized that only having the test data is not sufficient for actually having a practically useful benchmark. So we then started SuperLim 2.0, which is the project I will be talking about. And the idea then was to provide also training data for the test sets, which is what Språkbanken has been doing. And we have also come up with a set of baseline results and a reference implementation. And this is something we have done here at AI Sweden, which Tim will be talking about. And then we have actually a leaderboard also with all the results where you can compare models. And then Robin from KBlab will be presenting that. So we now have a final evaluation benchmark for Swedish language models, and it's called SuperLim. And the reason why it's called SuperLim is because of superglue. So glue is the general language understanding evaluation benchmark, and so we just literally translate it into SuperLim. So we'll hear first from Språkbanken, and Felix will start. Then we'll hear from Tim about the baseline results, and then last from Robin about the leaderboard. I think that's all, right? So Felix, I leave the word to you.
Thank you, Magnus. I have to share my screen then. Yes. So thank you. I'm Felix Morger. I'm a PhD student at Språkbanken Text, and I have also been involved in this project since we started 3 years ago on the SuperLim 1 project. So SuperLim 1, as we sort of mentioned, is a multitask benchmark for evaluating large-scale language models. And it is, as Magnus mentioned, a second iteration of the SuperLim project, and now we're releasing the SuperLim 2. And there have been some upgrades since SuperLim 1. So for one, we have 2 new tasks. We have more like proper splits of the different data sets for train, dev, and testing. And we have much more consistent data formatting. So every task has the same sort of structure to it. And we use one metric for all tasks, Krippendorf's alpha, which gives us a good aggregate sort of metric for how a model performs on all the tasks combined. So motivation for this, sort of what Magnus was alluding to, we know that large-scale pre-trained language models can learn a wide variety of NLP tasks. But now we have seen that multiple models are being trained and are set to be released for Swedish, but we haven't had like a good way of evaluating them. So we want to do like they did in the SuperGlue project, which is basically to release this set of tasks so we can do like a broad evaluation of the language capabilities of Swedish language models. So I'm going to give an overview of the tasks and the data sets and the tasks that we have. So we have 15 data sets for which 15 tasks are defined. And you have they represent a diverse set of different tasks targeting different aspects of written Swedish. One on the text level, which is where you have like a text of some sort and you want to make some sort of prediction about that text and score it with some value. And then we have the word level task where you have one word or like pairs of words or multiple words which you want to sort of predict something about. And then the third one, which could also be called like text level, but it's sort of a special kind of text level analysis, is logical inference, where you have two sentences and you want to sort of deduce the logical relationship between the sentences. And then we have some other tasks, which I couldn't so neatly get into these different categories, which are text summarization, multiple choice QA, and co-reference resolution. But I will get into those towards the end of the talk. And these data sets are released in a standardized data format in JSON lines and TSV, where each row is a sample to train with, and which includes task-specific features in each column. And then you use these task-specific features to predict a label, which is its own separate column. And then we also have an optional meta field, which can include like different meta information about the sample. And this sort of structure integrates well with Hugging Face and other deep learning architectures. So this is an like a table, an overview of the different tasks that we have. As you can see, we have two new tasks: augmentation sentences and SweDN for SuperLim 2. And as you can see, some have like a full train dev test split, while others, especially on the word level, we assume that you have to bring some own data to put these words into a context in order to sort of generate the necessary word embeddings to test. And as you can see, they're also of varying sizes, but this just reflects the like particular makeup of the available Swedish resources that we have been able to curate from. So now I will go through the different tasks and it's sort of to give you an insight into what it is you are actually will be able to test with the SuperLim test suite. So the first one is, I will go for the text level ones first, which is the first data set is the APSABank IM, where APSABank stands for aspect-based sentiment analysis, and IM is immigration. And here we are basically, given a certain sentence, we want to determine what the author of the sentence, or just the sentence general, or the utterance attitude is towards migration. So for example, if we have this example here, where someone is mentioning that they need to create a new party for Sweden, which in Sweden for focus on remigration and work. These are very like anti-immigration statements. So we would label this as a very negative statement towards migration. And what we do is we want to label this from 1 to 5. So either 1 being very negative and 5 being very positive. And this other sentence below is a more positive sort of utterance about immigration, talking about, you know, a society in peace, in harmony, multicultural, where different religions are sort of being able to live together. So that's the text, the APSABank data set. And we have the new data set for SuperLim 2, which is to determine an utterance stance towards a specific topic. So in this case, it's abortion. So whether the statement is pro or con, or doesn't say anything about abortion. So in this sentence here in the middle, someone is writing that even women will who wants to do abortions will do them even if they have to risk their lives for it. So that's sort of a pro-abortion or pro-availability of abortions stance. So that's why you would label it as pro. And then the one below here talks more about like that there are short-term and long-term physical and psychological risk with doing an abortion. So it's a label as calm. So the task is to determine the author stands towards a specific topic. And the next one is DALI GED, which is on DALI grammatical error detection, which is based on the DALI corpus of L2 second language learner essays. So we take, it consists of sentences from like second language essays. And what they have done in this data set is that they have post-edited them to correct any like errors that have been that are in the text. So for example, in this case, we have someone on the above, which is labeled incorrect. We have, so they have written har slutat instead of är slut for describing when a novel ends. And then the task is to be able to predict which ones are like written are naturally occurring sentences from this second language learning corpus, which ones are corrected. So it's a sort of sentence acceptability task. And the last text level task that I want to mention is the SWE paraphrase, where we just want to determine to what extent one sentence is a paraphrase restatement of another sentence. And you can give this a score between 1 to 5, or 0 to 5, where 0 means no, this is not a restatement at all of the other sentence, and 5 being like it's a very good restatement or good restatement. And so, for example, someone writes at the keyboard, someone's writing, we would say, yeah, that's restating what's the other sentence is saying. While a cat is going around the house, a woman is peeling potatoes, that doesn't have anything to do with each other, so you would give that 0. Oh. Then we have 4 different word level tasks. The first one is the SuperSim dataset, where we're testing for word relatedness and word similarity. So you usually say that word similarity is sort of like a subset of word relatedness. So relatedness sort of expresses more which words are like occurring in the same sort of context, while similarity is more like it says something about how the words are expressing the same thing. So for example, if you have these words påminna and glömma bort, which is remind and to forget, you would say that these words are very related, while so they occur in the same context, but they're not very similar because they're expressing the contradictory things, right? So they will get a low similarity score. And another example is vinna to lyckas. Vinna is to win, and lyckas is to succeed. So usually when you're winning, you're also succeeding, but that can be argued is not always the case. So they are very related, but they have lower similarity. So this is what we want the systems to be able to distinguish and score differently. And then we have the SWE analogy data sets, where you have given a word pair A and B and a word C. You want to find a word D such that A and B equals C and D. So you have the same, you find an counter example for like the same analogous pairing. So one of these pairings is a country city analogy. So Nassau, for example, is to Bahamas as Havana is to Cuba. So then model has to accurately predict that this is Cuba. And or country to currency, so Denmark is to kroner as the USA is to dollars. So that's the SWE analogy test. And then we have SWE word in context, where we have to want to determine whether 2 words in 2 different contexts, or the same word in 2 different contexts expresses the same sense. So in this case, we have the word inlägg, which means a post, And in this case, they're both in both sentences talking about a post in the social media. So because they're both talking about posts in social media, then we would say, okay, these two, yes, they are the same sense. So it's a binary classification task. So either it is the same sense or not. And the last one is SAT, which is from the Swedish aptitude test, which is or högskoleprovet, where it's a specific part of this, which is like an A-level test in Sweden, where in this specific section you want to pair a word to a correct list of synonyms, or to the correct synonym. So it's like a multiple choice task. So if you have a word like this, ingivelse, then you have 5 candidates and you have to pick the right word. In this case, impulse. And those were the word level tasks. So then we have the logical inference tasks, which is also called in NLP natural language inference, where the task is to determine the logical relationship between 2 statements, and a hypothesis, and a premise and a hypothesis. So, and then you would label this as either an entailment, contradiction, or neutral. So for example, if we have this sentence here, also in Swedish, varje italiensk man, or every Italian man wants to be a leading tenor. Some Italian men are leading tenor. This would entail this hypothesis that there are Italian men who wants to be leading tenors. Because if every Italian man wants to be a tenor, then there are some that wants to be it. So you just have to find this the logical relationship here. And what we also use the task, the task of natural language inference is also used in these different tasks, in, for example, SWE diagnostics, to target specific linguistics categories. So for example, morphological negation. So we have, in this case, 2 sentences which are exactly the same, but we're just changing one part of the sentence which express some sort of linguistic category that we want to diagnose. So in this case, it's unclean and unclean, and we built our society on unclean energy. This would contradict, we built our society on clean energy. And the only thing that's differing between these 2 sentences is the morphological negation expressed in the morphology of the word unclean. So if the model is able to correctly classify this inference, we would say like it can indirectly handle these sort of phenomena. And the same idea is applied in the SWE Vinnogender task, where we use natural language inference to evaluate gender bias. So if we have 2 sentences, so like the technician said to the customer that he, her, or they had finished the repairment, we would say that this entails the sentence. The message was that the technician had finished the repairment. So in the data set, we have 3 different instances of this sentence and this entailment, or this other sentence, and we have to say what. So if we see if the model is like, say that it's not does something different with the pronoun she, for example, then we could say, no, it's not correctly predicting, like it has some gender bias in the system. And those were the logical inference tasks. Now I will go into the last 3 remaining the tasks that I categorize other. So the first one is the SWE DN task, which is sourced from the newspaper Dagens Nyheter, where is a text summarization task where you have to, given this text article content, predict the preamble or summarization that is in the beginning of the article. So it's a good way of, or a smart way of creating a lot of data for a text summarization task. And then we have this VFAC data set where we, given a question, has to predict select the correct answer from a list of questions. And this is sourced from Swedish authorities' websites, for example, on 1177 about vaccination. So the question here is, I have an allergy, can I get vaccinated? Then you have to predict or select the correct answer. And these answers are sourced from the same category. The last task that I want to mention is the Vinnova, which is a co-reference resolution task where we have to determine whether a pronoun and a candidate antecedents co-refer. So if we have this sentence here with two candidate antecedents, we have to say, does this pronoun co-refer to one of them? So in the case of Steve and his, we would say, oh, they're not co-referring, but in Mark and Hans, we would say they're co-referring. So we have to determine which candidate antecedent this pronoun is referring to. So those were all the tasks, and you can find the data at the moment at GitHub, where we publish the official data, the releases, and also on Hugging Face, which sort of mirrors this, the releases on GitHub.
All right. So my name is Tim, and I work as an AI developer at AI Sweden. And our part in this project was to provide some baseline results for the task that's just been introduced, so we can have some common ground on what you can expect from the current models out there. And feel free to beat those baselines. Right. So, as already mentioned, we grouped those tasks to two clusters. Tasks that has to do with word levels, like are words synonyms or how similar are words to each other, and tasks that are more text level oriented, that contains more than one word, like phrases, sentences, and whatnot. And those are usually classification tasks or regression tasks. And yeah, so our job was to first verify all the SuperLim tasks, that they could be solved with machine learning, and provide some kind of starting point of the leaderboard and something for future models to outperform. So we're not saying like this is the best you can get, like this is just some common ground you can work with. And so first job was to select some existing models. So we took the most promising Swedish models we found out there and some multilingual models. And we also did some tuning of those models, like we did a small hyperparameter search for the learning rates and batch sizes, just to squeeze out some more performance. And of course, here you can go really deep and run experiments for days if you want something better. We don't have that much time to do that. All right, here's a little list of all the models we have used for the tasks. Not all models are used for all tasks, but those are all the models that have been used in the baselines. So first off, some really simple baselines. We go back to dinosaur age. So we have our old support vector machines with the bag of word representations, random forests, and some dummy classifiers that basically just looks at the label distribution in the training set and perhaps guess the most frequently seen label. And we also have the good old word2vec model for some of the word similar tasks. And for the BERT encoders, we have picked a few ones from KBlab and also one from AI Sweden and from the Norwegian AI Lab. And also took two multilingual BERT models that contain Swedish. And for the decoders, GPT models, we took 4 of our smallest models here at AI Sweden. So we do have 2 more models, the 20 billion model and the 40 billion model. And, but we didn't have time to run them on all experiments, so they're excluded here. And yeah, this is just a interesting plot where we saw like which models that were trained were the most sensitive to the selection of hyperparameters. And apparently the AI's Nordic's BERT model was not so sensitive. It performed quite the same regarding what hyperparameters was used. And the largest multilingual model in the bottom was very sensitive to the selection of hyperparameters. And all of those are in the GitHub repo also, the results. All right, so we got some data set from Språkbanken, and first step was to convert it to a form that we can use for machine learning. And here are some examples of the document level tasks or the text level tasks. So for example, the SWE paraphrase task, we can basically train on it as it is. Basically just needed to rename the attributes a little bit to make them work with the Hugging Face dataset framework. So just rename the score to labels and not so much more than that. And this we just trained a regression model on, where it tried to predict the score based on the 2 sentences. So we present the sentences and we put a separator token in between them, and we predict the score of how similar they are to each other. And we also have the DALI task to determine whether a sentence is correct or not. So the original data we got was 2 fields, like one original sentence that has the wrong grammar, and that we assume is, we assign that to label 0, and the other one is the corrected version we assign to label 1, and we treat this as a binary classification problem and just train on it instead. And we also have the aspect-based sentiment task, where the topic is about immigration. And yeah, there's some sentiment and there's some entities mentioned here, and the sentiment is towards those entities, but it's not explicitly annotated that it's a negative sentiment to a politician here, but that's probably what the model will learn if it sees a lot of examples. And this we just treat as a regression task, where we predict the label. I think it ranges from 0 to 5 or something. So here it's a slightly bad sentiment towards the politician. And we also have the SWE FAQ task, where the data we got was a bunch of questions paired with some answers, and only one answer belongs to one question. So for example, answer 3 is answering question A, and question B is answered by answer 3. So we had to convert this to some sort of form that can be used for machine learning. And what we did is basically say, yeah, answer 1 is answering question 1. So that's assigned as label 1. And we just put a little separator token between those 2 strings. And question 2 is answered by answer 2, and so forth. And for the negative samples, we just took one random answer and assigned it to a question. And we made this so it was a balanced data set. So yeah, trained through binary classification, but when evaluated on the test set, it was done as 3 forward passes, because you take the question that you want to know if it's answered or not by answer 1 here, and you do the same for all of the answers, and you predict and you select or prediction as the label with the highest score. So here, for example, you see both answer 1 and answer 3, the model thinks is the right answer, but apparently answer 1 was slightly higher, so that would be our final guess. And in the case where it's predicting label 0, for all of the cases, we take the one with the lowest probability and say that is the correct answer. Though that not happen so much, but that's how we solve this problem. And yeah, the SWE NLI problem, as just mentioned, we see it as a 3-class classification problem. So train the supervised model to predict either of those 3 classes. And we then have the 2 phrases and have a separated token between them. All right, and some examples for the word level tasks are first off the word similarity task, which is how similar are 2 words to each other. And there are some ground truth provided by Språkbanken. So we have words vinna and lyckas, so win and succeed, and they're annotated as similarity 4.6 on a scale of 0 to 10, I believe. And you have the word student and president, and they were annotated as dissimilar. And I think this is the average of 4 annotators or something like that. And here, very basically, just look at the word vectors using word2vec and check how similar the words are to each other. And yeah, then we calculate the Krippendorf alpha compared to the predicted value and the annotated value. And we also have the SWE analogy task, which is the famous, like, was already described, like, what is Sweden minus Stockholm plus France, that's equal to Paris in some vector space. And this is what made word2vec famous back in the old days. So the first baseline is just using word2vec, Swedish word2vec, and looking up what the similar word is based on those word subtractions and additions. But we also did this with GPT-SWE, which turned out to work way better. So we just fill in the whole prompt as much as we can with the training set. And the prompt can currently take 2048 tokens. So we fill in the whole prompt with as many samples as we can, but represented as strings. So here they're not vectors. And we just see this as a text generation problem. And yeah, we on the line on the bottom, we have like, we want the model to generate Japan here. And we would use that as the predicted value. And here it's like unclear how much the actual minus and plus symbols make a difference in the prompt, but it was used there for syntax. And yeah, finally we have this högskoleprovet task where you're supposed to select which is the correct synonym to a word. And here you have the word cold, and you have the suggested word tree, or like icy, airplane, grass cutter, or cat food. I think those I made up, they're not in the real data. And this you can solve with word2vec again, just looking at what's the most similar word to the input word. But you could solve it slightly better with, like about double the performance with the GPT-SWE. And here we don't do it like a normal prompting problem. We look at the word and we see which is the most likely word in the vocabulary to follow up to this phrase. And we would pick the one with the highest position in the vocabulary and say that's our prediction. Yes. Any questions? If not, then I think, Robin, you want to show some leaderboard results?
Perfect. So yeah, now we have multiple tasks supplied by Gothenburg, Språkbanken. We have some baselines supplied by AI Sweden. So how do we best look at those things? And the idea was to have a leaderboard like the superglue leaderboard, which lets us decide which is the best model. And the first thing I want to say, there is no the best model. So a leaderboard generally gives us a performance overview of Swedish language model. And what we wanted to have is more or less a personalizable leaderboard. So we can sort, we can filter. And that is something that has bugged us a little bit about the glue and the superglue leaderboards. There is just one leaderboard. It's way too many results.
For me personally, the Glue leaderboard always crashes my browser, so I cannot even look at it. And I cannot really see different types of models. I don't know how big are the models. I don't know. Maybe I just want to look at a subset of the task, because I think that the MNLI task on Glue, for example, is not really showing the language understanding capabilities. So we wanted to do better, basically. We also not only show the test set results, but also the results for the validation sets, so that if somebody, well, it gives us both an idea, because the distribution of the validation set might be different than the distribution on the test set. So you can learn something from that. But also, since the gold labels for the test set are public, anybody can basically say, I will secretly take the test set and train on it and will have the best model. And everybody will think I have the best model. But then you can go there and look at the development set and say, this doesn't really add up. And yeah. And so we want to also enforce replicability, so that people that hand in their results, they hand in all the results. They also hand in which model they use. They hand in all the scripts and seeds and hyperparameters they use, so that anybody can just take those settings and redo those experiments. And this, in combination with the open test set, hopefully encourages some honesty. So I'm not saying that there's going to be somebody that is going to try to do that, but well, we prepare for that. So yeah, our requirements are make the results replicable. I think I basically said all those things already. And also that if you publish your fine-tuning code, we want to also have the seed that you use, because even that can change things. So we want to see, we want to be able to double check that actually this is what you did. If you use some extra data, this is completely fine. You just have to state that you're using it, and then you also have to publish it so that anybody can replicate it. Once again, we want to ensure trust, but we also want to share all those techniques that you maybe learned and applied for your super good new model, so that you share them with anybody else to reproduce those results and also use them in their own research. If you want to submit, you do this simply as a pull request via GitHub. Can maybe show the page. I mean, which is not very exciting, but this is a GitHub page. Here you have the evaluation scripts, some instructions on how to use them, how to hand in your data. And if you want to look at the previous submissions, you can just pull the repository and then just look at all the results. For example, personally, I'm not trusting AI Nordic's model. Yeah. And I can then just simply, shouldn't click too much on things, it might be dangerous. Well, we can directly look at the data, look at the test set and the development sets, and just download them. I think I should go to the web page before everything dies. So here we have the long-awaited SuperLim leaderboard. Pretty simple. You get some information who was involved and where it comes from, I guess the typical part. And let's just go right away to the results. And here we see that the best model, or the model on top, is GPT-3 6.7 billion. So congratulations. But if you look a bit more closely, then it only competes in 2 tasks. So that's maybe not the fairest of comparisons. And as we can see here as well, that there's a lot of white space, which is because most of the, or all of the encoder models have not been evaluated or on the word level tasks, and the GPT models have only been evaluated on the word level tasks. So I guess what we first do is take away all the word level tasks to clean up a little bit. Nobody has evaluated on the diagnostic data set either, so we take it away as well. We have no results for Sweden. And I think one is missing, 3 set synonyms. Perfect. Now we have cleaned up the leaderboard a little bit, and we can finally have a look. What is the best Swedish model? And of course, it's the model of the National Library. Well, we can also double check on the development set and see there still National Library has the best model. But what is a bit more interesting is that if you have a use case for your model, your use case might be closer to a certain task that maybe you want to use your model to test if this is correct Swedish. So you don't really care about any of the tasks except for Dalai. So you just sort what is the best model according to Dalai, and there you can see, yeah, it's still a National Library. I didn't plan this, I'm sorry. But yeah, so the idea is that there is no one best model. Your best model depends on your task. And as we can see here as well, the best model is a large bird, but maybe you have small GPUs, or you want to have a model that is a bit faster. So your best model for you will be a model that has fewer parameters. So you sort after the parameters, and then the size of the parameters, and you take the models according to these measures. But yeah, so we have a personalizable leaderboard. If you click around, you can have some more information about the tasks. The interesting part, I guess, is what measures are used. And if you're like me, then alpha, what is this? Accuracy, yeah, I know, that is good. Pseudo alpha, what is that? And then here on Sweden, I need to update this, it says rouge. This is also still known. So what are those measures? And you can learn more about that here as well. So what is Krippendorf's alpha and why do you use it? And we have, thanks to Gerlof from Språkbanken, a longish, a good introduction on why we're using this measure and not accuracy or F1 score, except for the Sweden data where we use rouge. And some information about how to use the leaderboard. And if you want to submit, like I said, you go to the GitHub repository, make a pull request, or if you're just interested in the data and want to do your own analysis, just go there, download the data, and see what happens. So any more questions before my computer dies again?
Yeah, I have a question.
Perfect.
When will it be available online?
I would like to say on Friday.
But
I'm not saying
you're saying
Friday. Hopefully. One thing to say maybe with the alpha measure is that it's a measure from -1 to 1. So if you're seeing some negative scores here, for example, for the random forest, then that is to be expected. In that case, it means that the random forest makes systematically bad decisions. So if it's 0, then it's random, and the random forest is worse than random. So that's good to know that those non-transformer baselines, except for the SVM, are basically terrible, and the transformer models perform much better. So that is, thank you, transformers. Thank you, Bird.
I already used this very coarse metaphor that I hope you will excuse me for, of comparing SuperLim to weights. So to a tool used to measure something. And again, if you excuse the crude comparison, now we have some tool to benchmark, to estimate how good Swedish NLP models are, which has not existed before. Now, that said, there are many ways how this tool can be improved and developed. And what I would like to do is actually to look at some possible improvements. No, another way. So yeah, I should call them desiderata or dreams for potential SuperLim 3 and so on, which would be great to implement. Pre-training data set is one thing we actually wanted to do and started working on, but didn't manage to finish. Currently, we compare models which have been trained on very different data. Like some have seen billions of tokens, some maybe have seen less, which is okay. It's still reasonable to compare them, but we might wonder if the training data which makes the difference or the model itself. And to deal with that, we could have a pre-training data set that all models have to be pre-trained on, and you cannot use any other additional data, like a separate track. Human baselines are always interesting to look at, as they have in SuperGlue. Do the models beat human performance, or are they way below it? What happens? Currently, we don't know. It's always good to have more data sets. They're difficult to argue with that. Better data sets. Now, I'm not saying that ours are bad, but some are translated from English, not all of them, but some. And even those, in some cases, training data are machine translated. It's never the case for test data. They are always gold, so to say, manually corrected. But even manually corrected data may still suffer from translationese effects. Actually, Felix is doing an interesting study of to what extent it is the case. But original data may be better in some cases. More manual control of quality, more manual corrections can be applied. We have not really done any control for artifacts or simple heuristics, whether it's possible to hijack the task by, I don't know, always picking the, to find some simple way to achieve unreasonably good scores, and so on and so forth. Now, it may be argued that the benchmark has to be adjusted to those models that are currently of interest. For instance, some of the word level tasks, they come from the period when people created them, original versions, with word embedding models like word2vec in mind, while nowadays people are more interested in GPT and stuff. We kept them since we thought even current models should be able to deal with those tasks, but maybe it might be worth to complement them with some other newer tasks. As Robin already said, it's possible to cheat using test data, or we're not that much concerned about cheating. We have trust in users, but unintentional data leaks are also possible. If the model is trained on everything it could have reached by crawling, it may inadvertently just have seen our test data. So hidden test data could prevent that. And also, we would not like SuperLim to fall victim of the Goodhart's law. So when a measure becomes a target, it ceases to be a good measure. Now, if people start trying to achieve good scores on SuperLim, it's sort of meaningless. There is no point in achieving good score in SuperLim as such. SuperLim is a solved task. It is gold annotation. It's just an attempt to estimate how good your model would be when applied to some other unknown downstream tasks. Yeah, there have been suggestions how to. It's a problem for all NLU benchmarks, and there are various suggestions how to prevent that, how to deal with that. Maybe we could try implementing some of them. So there are no specific plans for doing when and how it will be done, but it would be good to have it done, I think. So let me finish with this slide that congratulate everybody on the work that has been done, but not forget that much more can be done. Thanks.